Hey, I guess today I'm gonna talk about a little bit about physics and some things. I'm not gonna talk about physics like E equals mc squared, la la la, but I'm gonna talk a little bit about how learning physics has been for me, because I'm in AP physics right now in high school. It's my first year of it, so just regular, first year physics. And we are in the second semester right now. So I've gotten a good deal of physicsy stuff, and I like physics a lot. Um, as a subject or as a topic because it uses calculus. It's really a lot like a math class, I think. It's really like calculus 2. It is applied to the world around us in a way that calculus generally isn't, but so in a way it is an application of math, but I see it a lot as an math class. We do all the problems we do in the textbook are calculations where the answer is a certain number, but there are some things that really bother me in all classes. Something that bothers me is when something happens that I perceive to be memorizing more than learning. This happens a lot in math classes when we are told this is the equation you use to get the answer. This is how to get a good score on the test, without really understanding why the equation is the way it is, or exactly what we're the processes that we're going through mean. And so I see that to a degree in physics. Now, our physics class, our teacher is Miss Martin, and I don't really listen to what she says just because she's very good at explaining things in the sense that she is good at explaining it so that you understand how to do the problems, but she just simply doesn't really take the time to explain the deeper meaning, which is a certain way of teaching, and I can see how saying all that might just confuse the students. So she's trying to be clear and concise and help them get a good grade on the AP exam, which is probably all the only thing most of them care about, to be fair, is getting a good grade. So she's on the AP test, so that's what she's trying to help them with. And she does a good job of that, but she just doesn't take the time to kind of give the deeper meaning. I always use the phrase deeper meaning, where it's a deeper meaning. But, so I have to try to find it myself, and I have to kind of struggle with that and understanding exactly how the equations were derived. Now, our textbook does take the time usually to show us the derivations of the different equations that they use, but it can still be kind of difficult to understand, especially when you don't have really as much of a reinforcement from the teacher to really explain the theoretics behind the concepts. So I can struggle with that. That's kind of me complaining about the class, but kind of on a different note, I have some problems with the way, well, one thing, I have a lot of problems. One thing is variables. I don't like variables. We use variables in math, and I never had a problem with them, but I guess in math, the variables tend to be completely baseless. So you have a function f of x, and the function isn't anything except a function of x, and x isn't anything except x. Perhaps it is position, but in physics we have x, y, v, a, p, I don't know. There's different variables for different things, and the problem is there are multiple variables with the same, that begin with the same first letter, that begin with the same letter or have the same first letter. So there's, I can't think of any at the moment, but there are definitely different things that have the same first letter. I should be able to think of something, but yeah, I actually can't really think of anything right now, but I'm sure that there are different quantities. Well, okay, we also have abbreviations of units. So the gram is usually symbolized by a lowercase g, like 5 grams, 5g. But then g can also stand for 9.8, which is the acceleration due to gravity, or the absolute value of the acceleration due to gravity. So those, there we have one variable for the same thing. And then they'll have different things, like the variable for density is apparently p instead of d. I don't know why. I'm assuming it's because there's something else for d. But anyway, it gets confusing. Sometimes the variable that they choose isn't even, like, starts with the same letter. I don't know. I can't really think of any examples right now because I'm being dumb right now. I don't know. Well, for arc length, they choose S, which is kind of arbitrary. We're doing some stuff with arc length right now. So I just literally write out all the words. Like, I can show you some of my notes for physics. Yeah, here. So look, this is what I was just writing 1 second ago. Can you see that? Wait. Kinetic energy equals 1/2 rotational inertia plus, I can't read it backwards, inertia through center of mass plus mass times radius squared. And I write out all the words just because, I don't know, I guess I got fed up with variables, so I just do that now. But that's kind of annoying, and I want to, like, I guess what I would use variables if they had a completely, like, logical way of assigning them. So, like, so that there were no overlap. Like, I need some kind of committee, like some kind of overarching international physics committee to assign the variables, and they need to have a very particular way of going about it. Like, maybe they just need to randomly assign them, like, get a computer generator to take all the, most of the different variables that there are in physics, velocity, temperature, I don't know, different stuff, and then just, there's more than 26, so they need to make up symbols like star, heart, smiley face, I don't know, whatever they want, and then assign them, and then print it, and then I will use that. But I don't know, because sometimes there are variables that different textbooks use different variables. I don't know, it just disturbs me on a deep psychological level. I'm not even kidding. So, oh my gosh, and I could tell a story about that. Actually, alright, I'm gonna go, I'm not gonna, there's a lot more that I can complain about physics. I want to complain about so many different things. I'll just try to make it brief, because this video is getting long. One thing that I really hate, which is really what I set out to talk about in the first place, is that they make things very convenient. So, for example, the equation for kinetic energy is 1/2 the mass times the velocity squared. When this is rotational kinetic energy, the equation is different. It's somewhat similar, but it's different. So what they do is they make up variables out of convenience. They're convenience variables, and they make up these variables so that they can reconstruct the equation similarly. So in kinetic energy is 1/2 mass velocity squared. Rotational kinetic energy, instead of the mass, they have what's basically the radius squared times the mass. So it's a different equation, but they made up a variable for radius squared times the mass, a convenience variable called rotational inertia. They take this variable and they plug it in, so now it's 1/2 the rotational inertia times the velocity squared. Look, it's the exact same equation, just with it's the exact same equation structure, but that's only true because they've created these convenience variables. So they do use a lot of algebra manipulation to make things appear magical, as if everything all the stars align, and like even the concept of energy transfer and the conservation of energy is only true because of their definition of energy. Why is kinetic energy 1/2 mass times velocity squared? Just because that's the antiderivative of work. So it's kinetic energy itself is convenience variable. It's not really an intrinsic thing per se. And the entire idea of conservation of energy, every time they find a new type of energy, they just make up a new name of energy so that energy can still be conserved. So every time that law of conservation of energy seems to be broken, they make a new kind of energy so that it isn't broken. So there's all these concepts that seem to be intrinsic concepts in nature, but they're actually human constructed. The stars aren't actually magically aligned like that, and so it kind of manipulates how we intuitively see physics itself. The way that physics is represented doesn't really parallel intuitively the way that it intrinsically exists in the universe. To me, I guess. There are different ways, like, you could, many different people, I think similar to how there's Euclidean geometry and then there's non-Euclidean geometry, there are a lot of parallel ways that you could express physics that would still be accurate, but that could be very different. So we have a standard way of expressing physics, and it uses a lot of convenience. That's how I see it. Instead of trying to... this video is gonna be really long, but you know what? Whatever, because I have to complain about something else. Radians. So a circle has 360 degrees, or it has 2 pi radians. Well, where'd they come up with that? So, as a kid, you always learn a circle has 360 degrees, and, you know, a right angle is 90 degrees, because that's a quarter of 360. So, now there's another way of measuring angles, which is in radians. And instead of a circle having 360 degrees, it has 2 pi radians. Why 2 pi radians? Because the circumference of a circle is 2 pi times the radius of the circle. And so this is very convenient. It's a very convenient way of measuring things. If we take a slice of a circle, like if a circle's a pie and you take a slice of the pie, you know, how do you determine the arc length? Now I'm going to go back to arc length. How do you determine the arc length? So let's say the piece of pie is 30 degrees. We take 30 degrees of a circle. How do we figure out the arc length? Okay, well, we have to figure out what fraction of the circle we took. So we do 30 divided by 360, which is, I don't know what it is, but we do that. Here, ready? 30 divided by 360 is 1/12. Okay, so that's 1/12 of the circle. Now, we have to multiply that by the circumference of the circle. The circumference of the circle is 2 pi times the radius. So we multiply that by 2 pi to get 1/6 pi, and then multiply by the radius of the circle. That's how long the arc length is. Now, in radians, 30 degrees is 1/12 of the circle. So we multiply that by 2 pi, and it's that many radians. How do I explain this? But by making the circle, an entire circle, 2 pi, it's like, so to get the arc length, you do 2 pi times the radius times the fraction of the circle that you're taking. By measuring the angle out of 2 pi, you're effectively already multiplying by 2 pi. I don't know how to explain this. To get the arc, so normally to get the arc length, you divide by 360, you multiply by 2 pi, and you multiply by the radius. By measuring in radians, all you have to do is multiply by the radius. So it's a very convenient way of measuring degrees, in that when you're working with the numbers a certain way, it's very convenient because you don't have to divide by 360 and multiply by 2 pi. You've already done that. It's very convenient, but then the arc length is just the degrees in radians times the radius. It's so simple. Wow. You know, arc length is the degrees theta times the radius. Wow, it's so simple. Look at that. That must just be part of the simplicity of nature, you know? And it's it creates an illusion of simplicity that doesn't naturally exist, which is, I guess, just a personal complaint, but to me, it kind of prioritizes convenience over actual understanding of something. Now, this is all a rant by someone who knows very little about physics, so I admit that a lot of what I'm saying is probably pretty ignorant, but this is how I feel, and I have some knowledge of physics. I try. But okay, now I'm going to tell a story. I'm sorry this is really long, but I have to tell a story about statistics. I'm in AP Statistics right now. I took AP Calculus last year. Statistics and calculus are very, very different. I had an amazing calculus teacher, and he taught me, he really created a passion for me for math, and statistics is different in that it's different from calculus, and it's different from really all other types of math in that it works a lot with convenience. It works with convenience. One of the basic things about physics is the normal curve, which is like a kind of a perfect distribution that doesn't really exist, but you use a normal curve kind of as an approximation. It's very approximate as opposed to being exact, which calculus is exact, physics is exact, physics being a lot like calculus. And this was really hard for me to understand. So when I first started statistics, I feel like this looks really creepy for some reason. When I first started statistics, it was hard for me to understand that, and I don't remember exactly what happened. I just remember reading the textbook and crying. I think one thing that bothered me was that they kept using the median instead of the mean, and that really disturbed me for some reason. The mean is, I guess, still in my opinion. Again, I'm not a statistician, so what I'm saying is probably pretty ignorant, but it's still how I feel, so I'm just saying how I feel. I'm not even really trying to make points here, because I'm not smart enough, or I'm not knowledgeable enough to actually suggest changes to serious academic fields. But the mean, in my ignorant opinion, is the best way to figure out the average. They use the median because it's less resistant to outliers. Okay, so this can be more convenient if you are trying to collect data on something and there's an outlier which is messing up your results. Now, my problem with statistics is that it hates outliers. It treats outliers like outcasts, which is rude, because everyone is an important part of this society. So statistics is racist. No. Yeah, that's kind of a joke, but it really doesn't like outliers. There are tests to determine whether something should be considered an outlier and whether we should shun it or not. And it's like, my problem with it is that if you collected enough data, the outliers, well, I guess there would be outliers, but the outliers would not affect the data in a negative way. So the problem with outliers is that they mess up the data when the sample size is small and the outlier is just a coincidence, as opposed to happening the entire... My sisters are singing like princess songs and where, yeah, outliers, blah 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 blah. So they use the median to avoid the pull of the outliers. However, if you had the entire data set as opposed to a sample, you would want any outliers, you would want all of the information, most likely. The problem with outliers is when you have a small sample and you're trying to make an estimation and you know this outlier is just some random mess up that's gonna mess you up. If that makes sense. So they use the median, which you lose things with using the median and you gain things with using the median. Another thing that they do is, in order to find, so median are ways of finding the average. In ways of finding the average variance, they use the standard deviation as opposed to the average absolute deviation. So the way to find the average absolute deviation is what you would think. So you find the mean, the average, and then you find all of the differences from the average. So if we have 1, 2, and 3, the mean is 2. 1 has a deviation of -1, 2 has a deviation of 0, and 3 has a deviation of 1. That's how far they are from the mean. So then we add those up. Well, first we take the absolute value, meaning we make all the negatives positive, and then we find the average, we find the mean of the deviations. So you find the mean, you find all the deviations from the mean, make them all positive, and then find the mean of the deviations. That's the average absolute deviation. Makes sense. The standard deviation is similar, except instead what happens is you take the mean, you take the deviations, you square all the deviations, you find the mean squared deviation, and then you take the square root of that, which sounds unnecessarily convoluted. Why do they do that? different reasons I've heard. I've heard one, I think, is that it's useful for the normal curve, which is this convenient invention. So that's one reason that they do the standard deviation instead of the average or absolute deviation. Another I've heard is that, again, it's less resistant to outliers. Another I've heard is that calculators and computers have trouble taking absolute values for some reason, and when you square a number, it always becomes positive. So I've heard that it's easier for computers to compute. I don't know, there's probably a lot of different reasons that they use standard deviation instead of what you would intuitively expect, the average absolute deviation. But my point of concern is that the standard deviation is somewhat arbitrary. They use it instead because it's more convenient. They could use something besides the standard deviation. They could use maybe the double standard deviation, where they take the deviations and cube them, and then they take the cube root. That wouldn't be called the double standard deviation. I don't know what it'd be called, but there are different ways that they could, there's probably a lot of different ways that they could go about solving those inconveniences, and there are many probably different ways that they could find an average deviation, but they chose this one and settled upon it arbitrarily out of convenience. And I guess when I said that it disturbed me on a deep psychological level, in a way I wasn't kidding. I really do remember in the beginning of statistics reading that and just crying and being so upset because it wasn't exact, I guess. And because what was going on wasn't information about the universe and about the world around us and about, look at this, it falls at 9.8 meters per second, look at this universe. It's, what are we going to choose as the most convenient way to go about approximating something? And I know that statistics is important. They've built a whole academic subject around it, and it's important, and it's very useful for a bunch of things that are very important, but that doesn't stop it from making me want to pull my hair out and cry. I didn't really pull my hair out, but I really did cry, and then I eventually kind of gave up on taking much of an interest in the subject and kind of treat physics as my math class instead. But that kind of thing does actually deeply disturb me. I don't know why. And, you know, maybe if I had given statistics a fair shot from the beginning, I would feel differently about it. But now it's just kind of like my enemy. That's all I'm gonna say, because this is really long and it's just a rant, and I'm not really educated on any of these subjects, so I wouldn't buy too much into what I say, but that's just how I feel about them as a student of them. Thanks for listening.